Hi, Assalamualaikum. In this video, we are going to discuss about the topic of application maximum and minimum, which is an application of differentiation. Alright, so before we are solving the questions, firstly we have to read the questions carefully and then we have to transform the sentences into mathematical formula depending on what the question is asking for. Next, we have to find the dy over dx. So this variable could change according to the variables given in the question. It can be dx, dA over dv, and it depends on the question. Alright, after finding dy over dx, we have to let it equal to 0. So, we know that when we let dy over dx equal to 0, meaning that it should be the either minimum or maximum. So, because when we have graph something like this, right? At the turning point here, we know that dy over dx is actually 0. And when we turning point like this, the dy over dx is actually also equal to 0. So to check that it is either minimum or maximum, we have to find the second derivative. So where we have the rules for the second derivative, test it du square over dx square is greater than 0, it's actually minimum. But if it is less than 0, so it should be maximum. So to illustrate these 4 steps I have been mentioned about. So let's see some example.
My name is Kuzaima binti Amizaki, and today I will be discussing with you one of the questions of applied maximum and minimum problems. So a question states that a figure below shows a right cylinder closed at both ends as a radius x and height y. So the question has given to us a figure where it states that the radius is equal to x and the height is equal to y. So the first question, it says that if the surface area of the cylinder is 150 pi cm squared, then write y in terms of x. So it is important in this question for you to remember the area formula for the cylinder, but sometimes the question will provide it for you. So the formula for the surface area of cylinder is A, which is surface area, equals to 2 pi r squared plus 2 pi rh. So we can use the information given, which is 150 pi cm squared, which is the area, and we can put the information in, and we can change r, which is equal to x, and h, which is equal to y. So it will be 150 pi equals to 2 pi x squared plus 2 pi xy. So as you can see here, we can factorize 2 pi from both of the equation above. So 150 pi we divide it by 2 pi equals to x squared plus xy, and we will get 75 equals to x squared plus xy. And then we just move the x variable to the other side and leave y on the other side. So in the end, we will get 75 minus x squared divided by x equals to y. So for question 1, we have found the answer where we already write y in terms of x. Next, for question B, it says that prove that the volume of the cylinder is V equals to 75 pi r minus pi x cubed. So the first thing that we need to do in this question is to write the formula for the volume of cylinder, which is V equals to pi r squared h. So just like the previous question, we need to change r and h to x and y. So we will get V equals to pi x squared y. So as the previous question, we can actually use y equals to 75 minus x squared divided by x into this equation. So we will get v equals to pi x squared, and then you substitute the value of y from the previous question, and then we will solve it by multiplying pi x squared into 75 divided by x minus x squared divided by x, and we will get the final answer as v equals to 75 pi x minus pi x cubed, just like the question stated. And for the last question, which is question C, it asks us to find the value of x such that the volume of the cylinder is maximum. So when the question says for us to find the value of x or y or anything, and it says that the volume of the cylinder is maximum or minimum, so there are 3 steps that you need to do for this question. So the first step is to find the derivative. So we use from the previous question the equation of v equals to 75 pi x minus pi x cubed. So we need to find the derivative of v. So dv divided by dx is equal to, so we differentiate the equation, we will get 75 pi minus 3 pi x squared. And then the second step is to let the derivative is equal to 0. So we will write the equation as 75 pi minus 3 pi x squared equals to 0. And then we will find the value of x. So we just move to 75 pi divided by 3x, and then you can press the calculator and solve this, and you will get 25, and then you move the power of 2 and you will get square root. So the square root of 25 is 5. So you will get the answer for x is equal to 5 cm. That is the second step. So for the last and third step, you need to test it by using the second derivative. So dv over dx is equal to 75 pi minus 3 pi x squared. So you need to find the second derivative, and you will get negative 6 pi x. So you substitute x, which is equal to 5, into the equation, and you will get negative 94.25. So the value of this is actually less than 0. So when the value is less than 0, so x equals to 5 cm is a maximum value. And for that, we have solved for question C.
Assalamualaikum, my name is Anisha Kira binti Azharis. Question: a farmer has 1,200 meter of fencing and want to fence off the rectangular feeds that border a straight river. He did not fence along the river. What are the dimensions of the feeds that has the large area? Okay, means here, first you need to draw the rectangular. Farmer said that he need not fence along the river. Means here is the river. Okay, so area of this rectangular is area equal to length multiply with width. Means here a equal to x, y. Automation given said that 1,200 meter is around this area. Okay. So here 1,200 meter equal to x plus 2y. Okay, means here x equal to 1,200 minus 2y. Okay, next we need to substitute this x into the area formula. Okay, so first a equal to 1,200 minus 2y multiply with y, and then we will get 1200y minus 2y squared. Okay, next we need to do the first derivative, dA over dy equal to 1200 minus 4y. Okay, so dA over dy equal to 0. Means here 1200 minus 4y equal to 0. And then the value of y is 300. So next we need to do the second derivative. Second derivative, d squared a over dy squared equal to negative 4 less than 0. Means here it was maximum. Okay, next we need to find x value. Okay, so x value we need to use the area formula, which x equal to 1200 minus 2. We substitute y as 300. Okay, so we will get 600. So next we need to find the maximum large area. So we need to multiply 600 with 300 and then we will get 180,000 meter squared.